Hey, what's up everybody? This is the Helpful Hacker, and today we are going over TryHackMe's OWASP Top 10 room. This is from 2021. So we'll jump right in and we'll get started with task number 1, the introduction. So pretty much this room is just going to talk about each OWASP topic. They're going to talk about the different vulnerabilities. We'll go through them. Some of them have really good examples, other ones have examples. And yeah, so you can read through that, mark complete. And with that, you are done with task number 1. Now it's on to task number 2. This really easy. They're just gonna help you out to actually access the target machine. So you can use the in-browser Linux machine provided by TryHackMe. That's what I'm using right here. Or you can connect over OpenVPN. If you follow this link, it'll tell you how to do that if you want to use your own machine. So with that, hit start machine, and then once you're all set up and connected, you can mark complete. And with that, you are done with task number 2. Now it's on to task number 3, broken access control. Okay, so task number 3, they're basically just going to tell you a little bit about broken access control. You can read about it, and then they give you a nice example down here in the last paragraph talking about an actual vulnerability that was found in 2019. But what you really should take away from this, because you'll get some experience with it down here when we do this insecure direct object reference, I think that's what it's called, yeah, challenge. So when we do that, you'll get kind of a better idea of it. But for now, just read through this and know that really what it's trying to say is just that broken access control is a vulnerability that when it happens, it allows an attacker to bypass authorization. Right? And if you can bypass that authorization, then if that allows you to access or view sensitive data or do things you're not supposed to, that's broken access control, right? The control that we should have over who accesses what resources is broken. So it's all in the name, pretty straightforward. But you get to understand these concepts a lot better as you slowly accrue more examples of them actually happening in real life or in a lab or on something like TryHackMe. So read through that, mark complete, and with that, we're done with task number 3. Now it's on to task number 4, where we actually get to have some fun. Okay, so this is going to talk specifically about insecure direct object reference. So I'm going to real quickly try to sum this up, and then we'll actually do the example. So basically, if you look here, there's this URL, and it says ID 111111. And so that's a direct reference to the ID of this account. That's how this is being identified. We can see the account number and it's right there in ID. So the reason why this is a bad idea is, one, because this is easily guessable. That probably means you have at least this many bank accounts, right? If not more. So then I could start changing this number and guessing different bank account numbers. And maybe if the application, the web application isn't set up correctly and it's not doing all of its proper checks for authorization, I just might be able to access somebody else's bank account simply by changing that number, right? So we'll get more into this as we jump into the example, and then we'll explain how most applications work, because most applications do not allow you to do this, because that would be bad news. So make sure you read through everything, mark complete, and then we are going to copy this. And let's open a web browser is what we're going to do. And we'll navigate to that website that they give us. So the website here, they're just doing whatever IP address your attack or your target machine is. That's what I should say. Okay, so here we go. We have this, and it looks like a login page. So let's jump back and see what they want us to do. They want us to log in using Newt and password test1234. So let's try that. So if we log in, don't care about that. Now if we look, things to buy from the store, 2x carrots, 1x potato, 1x cheese, lots of chocolate. So a normal thing to do, I'm not going to do it, but just something to get into the habit too whenever you do any sort of CTF or honestly any website analysis. View the page source, get an idea of kind of how things are working. But for the sake of time, I'm going to skip that because I know how this works. So up here, if we look at the URL, we have this note ID equals 1, right? And that's the exact example they gave us. So let's try changing it to 2 and see what happens. So now this is the THM note server, and we can see we have different notes here. So we can start clicking through up here and trying to figure out what note has the flag, because we can tell that's how this is going to work. So we're on the right track. We'll go to 4. Mark's New Year's resolution. Let's see. This is kind of a tedious process. Do note IDs start from 1? Maybe go lower. Okay, what's lower than 1? We could go 0. And there we go. We have the flag. So we can copy that. We'll come over here and paste it. So you can mark that second question complete once you've logged in, and then mark that complete. Okay, so we can see if a website insecurely references something, and it doesn't just have to be up here in this. This is a very simplified example. There's more complex examples of insecure direct object reference. But basically, if a website is referencing something directly, sometimes that can be dangerous because it gives us an opportunity to try to change that into something else to see if we can point the website to something else in the server, maybe something it shouldn't show us. Now, in real life, most websites, they use what are called universally unique identifiers, or sometimes they're called globally unique identifiers. I don't know why there's 2 words for it, but basically they're long randomly generated strings so that we can't guess, right? Because in our example, we were able to guess 1, 2, 3, 4, 5, right? It was really easy. In actuality, it would be like a super long string that's very random, and that's what a secure website would use up here. But even using that wouldn't be enough because we could still randomly guess that number based on other things. We could make multiple accounts and see if maybe there's a pattern or a general format. And even if it's unlikely, we could run an attack that would cycle through millions of numbers over time. So that doesn't totally do it. Using universally unique identifiers is a great idea instead of using like normal IDs like this, but that still doesn't fix the problem. So what really fixes the problem is just proper authorization checks. So anytime that you reach out to the web server for something, especially something sensitive, the web server should be checking, hey, are you who you say you are? The web server should be checking to say, are you authorized to actually see this other person's bank account? So that's how most websites work today. You can still find these vulnerabilities though. It's not like they don't exist. And there are even old websites out there that are still probably running important stuff that even have something as simple as this exact vulnerability, but it's not super common. So hopefully that helps. Once you've done all that, you can mark complete. And with that, we're done with task number 4. Now it's on to task number 5, cryptographic failures. Okay. So basically all a cryptographic failure is, it's any vulnerability that comes from either the misuse or no use at all of cryptographic algorithms, right? So we can use cryptographic algorithms to encrypt stuff. And if we're using an old cryptographic algorithm, then that's a vulnerability because maybe somebody can actually decrypt that. Or maybe we should be using cryptographic algorithms on things, but we're just not, right? So those are the kind of vulnerabilities that generally arise from cryptographic failures. So you can read through this, learn a little bit more about it. They do talk about data in transit versus data at rest. I'm not going to get into that just because you can read about it, and I don't think that's the most important thing to take away from this. So read through it, mark complete, And with that, you're done with task number 5. Now it's on to task number 6, supporting materials. So when this says supporting materials, basically in the next tasks, specifically I think it's task number 8, we're going to have to use some additional skills, and they're providing those skills right now. So in this first supporting material, they're just teaching us about SQLite 3 or SQLite 3, however you say that. I don't know. It's an SQLite database, which basically is like an SQL database, but it's like in a really nice little compressed file thing, I think. But anyways, yeah, right here. It's a flat file database. So they're just teaching us that this is a tool that we can use. You can use it right in the command line, and it gives us some common commands. So to open up something, you would do SQLite and then the name of the database. And then from there, you can see the tables by doing SQLite. Again, I keep saying SQLite, but this is SQLite 3. I think that's how you say it. That's how I would say it. So SQLite 3. And then you can do the actual tables just by doing .tables. That's the command. And then you can dump everything from those tables by doing a select all from customers, assuming customers is the table that's in your SQLite database. So you can read through that. Hopefully at this point you've done a room on SQL databases and you should be a pro at this. If not, check out my channel. I have a room that talks about, SQL databases. So you can take a look at that. But yeah, read through this. Make sure you have a good idea of just the commands here because you're going to have to be using them. And then you should know what an SQL database is. And I guess they also want you to know what a flat file database is, or an SQLite 3 database that we're going to use. I guess SQLite 3 isn't the database. That's the client. Yeah, that's not the actual database. You'll see what the database looks like. It's literally just a file on your computer. And I'm probably only talking so much about this because I just made a video about SQL databases, and a lot of them don't look like a single, they're not flat file databases a lot of the time. So that's what this is. But we'll get experience with it. I'm talking too much. So yeah, learn all the commands, go through here, and then this is the output that they have here. We're going to get some output that looks very similar. So read everything, mark complete, and with that, we are done with task number 6. Now it's on to task number 7, supporting material number 2. So now this supporting material, they're going to talk about cracking password hashes. So again, I've already made a video that goes pretty in depth on this, and if you're following along with like TryHackMe's pathway, you should have already done it. It's called Hashing Basics, I think. But basically, a hash is a one-way algorithm. So you can take a password and you can hash it, and then if someone gets the hash, they can't actually use that to reverse engineer the password. So what we do instead is we have a database of common passwords and we hash all of them. And so when we hash all these common passwords, then we have all of the hashes of these common passwords, and we can check another hash to see if it matches any of those common passwords. And that's called a dictionary attack. So if that sounded like a lot of gibberish to you, don't worry too much about it. Go check out the Hashing Basics room. But we're going to need to know how to crack hashes for this. So I just like to use it. I think it's what they're using. It's this Crack Station Online. So any online hash cracker should be able to crack the hashes that TryHackMe is going to give us, because they're not going to be crazy passwords or anything. They should be pretty straightforward. But if you want to know more about it, you can read through all this and it'll give you a real brief overview of how it works. But yeah, that's what hashes are, and most passwords are stored as hashes, and this is how we go about figuring out the actual password when we only have the hash. So mark complete once you've read through all that. And with that, it is on to task number 8. This is the fun part. So now we're going to port 81. So I'm going to go there. Okay, welcome to Sense and Sensitivity. What does that even mean? I'm not going to read through all that. Contact us here. That just links to an email. There's a login page. Okay, so again, I'm not going to do it for the sake of time, but you should right click on this, use the developer tools, take a look at the website, see how it's working. But I am just going to go straight to the questions. So have a look around the web app. The developer left themselves a note indicating that there is sensitive data in a specific directory. Okay, see? So this is why you should always just view the page source. Let's see, what do we got? This is login.php. I'll open that up. Oh, hello. Must remember to do something better than store the database with the database, then store it in /assets. Awesome. So now we can come over here, /assets. Oh, wait a minute. That's so not what I wanted to do. Come on. Here we go. Look at all this good stuff. Okay, before I get ahead of myself, what is the actual question? What is the name of the mentioned directory? That would be assets. Sweet. Navigate to the directory you found in question. What file stands out as being likely to contain sensitive data? Well, webappdb, right? You could click through all these and find out. And again, just to kind of understand the structure of websites, that kind of stuff, it's always useful to know. It's always useful just to explore. You often learn a lot that way. But we know it's this webappdb. DB stands for database. And we have been, that was part of our supporting material. So I'm actually going to download that. And you can do that just by clicking on it. So now what do they want me to do? I believe that was webapp.db. Is that right? Yes. Okay. Use the supporting material to access the sensitive data. What is the password hash of the admin user? Okay, so now what we got to do is I need to open up a terminal. So now that we have a terminal, I'm just going to do this, but if you're, you should be trying to do all this stuff on your own and then watch these videos, following along, you will learn, and that's not the worst thing in the world, but you get a lot more out of it if you try first. So if you're trying this by yourself, you can reference all this supporting material to help you through these commands. I'm just going to run through them because I know a lot of them. So back to my terminal. So the first thing we're going to want to do is SQLite 3, I guess. I don't really like the name of this client, to be honest. And then we'll do webapp.db. Okay, so now we're actually in it. And actually, you know what, before that, I just should, does that not get me out? Exit, does that get me out? Oh. I don't actually know how to exit out of this. Okay, whatever, fine. I'll just open up a new terminal or a new tab. And I only do that because I want to show you this. If you're using your own machine and you just downloaded this, it's going to go into downloads. And so you either need to travel into downloads in your terminal and run all these commands, or you need to move this webapp.db to wherever you're at so that this actually runs. I just wanted to make that clear because I get questions like that sometimes. So, okay, I should be able to .tables. Oh, you know what? I'm in webapp.db. That's not even right. What I need to do, SQLite 3. Come on. webapp.db. If you can't tell, the P key on my keyboard is super sticky and it's kind of driving me nuts. So now that I'm actually in the right database, this is the right one. I was in the other one before. So hit enter the .tables command, and now you have sessions and you have users. So in the question, we're trying to find the admin user password. So we're going to want to dump everything from users. So the way to do that is you can just select all. That's what the asterisk does. And from, and that is users, plural. Oh, and you got to end with the semicolon. So that's another thing that I always forget. I always forget the to put the semicolon at the end of everything. So now we have dumped everything from users. So we have this random string, admin, another random string, 1, and so on. So my guess is that this is all probably user information that is hashed, or maybe some of it's hashed. I mean, I know some of it's hashed because they taught us about hashes. So the password is hashed. I don't know what the other parts are, but what we're going to do is we're going to take this, and now I happen to know this is the password just because I did this not all that long ago. But in reality, if you don't, you could just take both of these surrounding hash or surrounding admin, and you could try cracking both of them, and eventually you would come up with the right answer. So we're gonna, there we go, crack hashes. Okay, so we paste in this hash into crack station. It's gonna run a dictionary attack for us with a bunch of common passwords, and it turns out QWERTYUIOP is the password, which is just all the letters across that top line of the keyboard. So what's the password hash? Oh, they want the password hash here. So we're going to paste that. I guess that is actually an easier way. Instead of getting both of these and trying to hash them, just copy it, paste it in here, see if they tell you it's the right answer or not. So now the admin's password, again, just that top line of all the characters on your keyboard, all the alphabetic characters. And then login as the admin. What is the flag? Okay, so if we go back here, we want to go to login. And that login was going to be admin, and then the password again, QWERTYUIOP. Say that 10 times fast. And here we go. We are admin, and this is our not our password. We know the password. That's our flag. So mark that, hit submit, and there you have it. So with this one, the cryptographic failure here, because they teach us a bunch of stuff here, which is it's all good information. Learning about, flat file databases and SQLite 3 and some basic SQL commands and hashing, all good stuff. But the cryptographic failure here is the hashing, right? The password requirements for this website are not sufficient. So the admin should just know better than to use such a weak password. So that's the actual vulnerability we're talking about here that's related to cryptographic failures, is the admin used a very easy password, and we can use a dictionary attack to get that password from the hash. Now on a real website, an admin should have a very complex password that we cannot get using a dictionary attack. So yeah. Hopefully that makes some sense. With that, you're done with task 8, mark complete. And now it's on to task 9, injections. Okay, so this one just explains injections. The next one is a fun one. So task 10. But anyways, so injections, it's like a broad type of vulnerability. You have SQL injections, command injections. Those are two that they explain. I think cross-site scripting now falls into the category of injections, even though I think maybe before it was its own category on the OWASP top 10. Someone in the comments should fact check that. I'm not totally sure. I think cross-site scripting is now an injection. I'm almost positive. And I think it used to be its own category. But anyways, injections are just like a very broad vulnerability, and it's where an attacker is able to manipulate input fields to inject malicious code in some way, shape, or form, right? So an SQL injection, they're able to manipulate they're able to manipulate like user input usually, so that instead of a normal SQL injection, you get one that dumps the entire database, right? Or a command injection. Sometimes web applications they shouldn't be, but sometimes they provide input that can impact commands, or maybe in our next example, the user input goes into a script, and then that script is going to actually run in the command line. And so because it takes user input that ends up in that command line, we can put other input that's malicious and then execute commands on the machine. That was kind of a roundabout way of saying that. I should have done better. But read through this. Hopefully it makes sense. But basically, the most common way that this happens with web applications is there's an area for user input. Maybe it's your name. Maybe it's your password. Maybe it's a blog post. But you're able to put input there. And instead of putting the expected input, you put input that then allows malicious code to run. And that, for the most part, covers pretty much all the injections. So yeah, read through that, mark complete. And one other thing, totally forgot. So these are a couple of ways to defend against this kind of stuff. You should be very careful about what you accept as user input, and you should have like using an allow list or a deny list or stuff like that, or having things get processed very carefully on the back end before the user input is actually accepted. That's kind of the method here to prevent this from happening. So keep that in mind. So mark complete. We're done with that. And you're done with task 9. Now it's on to task 10, command injections. So this is a fun one. And yeah, we're going to get into it. So I personally think that what I'm going to do is I'm going to skip all this. This is great explanation, by the way. You should read through their explanation. I'm going to explain it, but I always find it a bit easier to explain if I'm just kind of doing it. So, yeah. Okay. So, I'm going to show you how this works first, and then I'll go back and explain the application. So, enter the inner cow's mooing. So, I'm just going to say hi. And I'm going to come up here and I'm going to leave it at default and see what happens. So when I hit submit, the website gives me back a cow and it says hi. So that's my user input right there. I typed that in. So what if I'm just going to do a random string, and instead of a cow, I'm going to do a dragon. So if I hit submit, okay, now we have this ASCII dragon and it is repeating exactly what I said. Okay, so that's how this application works. We give it the text, and then we can pick from this, basically these options here, what we want to actually be the picture. So that's how the application works. Now we're going to jump back up here and look at the actual code for how this is happening. So this is a PHP script. If you're not familiar with PHP, it's okay. You can take this script. What I recommend doing, just paste that into ChatGPT or into Google, and you can usually get an explanation that kind of goes line by line for you. Anytime you see stuff like this, I always recommend people might be like, well, I'm not learning PHP, I'm learning Python, or I'm learning Bash scripting right now, or I'm learning something else. And so sometimes people are just like, I don't need to learn this, I'll learn it later. Honestly, if you just really dig into every single script that you run into, you're going to get so much better at just coding in general, and you might not be able to write anything fancy in PHP, but if every single PHP script and every CTF you actually dissected and learned how it worked, you would be able to read PHP for the most part. So keep that in mind. I always recommend doing this, but basically line by line, it's checking whether or not this mooing is set and all that stuff. And what it does here is it takes user input. Okay. So mooing equals get mooing, and this $ mooing and this $ cow, those are just variables, okay? So they're accepting these variables from us, right? And then if these are set, then it's using pass through, and then it has this thing. So read through that again, like I said, put it in ChatGPT and maybe learn a little bit of the syntax. That might help you more. I'm not going to go through all of it just because of time. But essentially what this script is doing is it's asking us for the mooing, which is what we type in here, right? So that's the mooing. And if I submit, it gives me that back. And then it also asks for the cow. And the cow is up here, whatever I happen to pick, right? So that doesn't look like a cat. I mean, it does, but it doesn't look like a house cat. Anyways, I'm getting distracted. So that's mooing and cow. Now, after that, it kind of does checks for that, and you can learn all about that, but it's not really important. What matters here is this pass-through function. So what pass-through does is essentially it takes whatever's inside of it and it passes it directly to the command line. Okay? And this is important. So they're taking our mooing and our cow, they're putting it right here, and then they're taking this, so everything that I've highlighted in blue, and they're just putting that in the command line, and then they're running the command. Okay? And this command, they're just running a script, and it accepts cow and mooing as input, and then the output of that script is this stuff. So that's how they're doing this. They have a script on the back end, and we're submitting information, specifically whatever we put here and whatever we put here, right? So it's going to take those two pieces of data, and I'll show you how it does this. So we hit submit, and now if I look, cow equals small, mooing equals, and that's the exact number that we put in. So it takes this URL, it sends it, and puts this data, the small and 4564654, and it takes those, puts them in this part right here, and then just executes this script with that input. Okay? So that's how the application actually works. And they show you that here. So you can read through all of this if you want more of an explanation. Now, the reason why this is dangerous, it's dangerous for a ton of reasons, but another thing that we can do is we can do what is basically called, what's the name? I think it's called command substitution. Yeah, so I think this is called command substitution, and basically what this does is they give you an example here, echo, my username is $, and then in the parentheses, you put your command, and that command is who am I? So then when you run this, first, it's going to execute the echo command. Well, actually, I lied. I don't know why I said that. So first, it's going to execute this who am I command, right? And when it executes that, it gets the answer JDO, and then it's going to put that back into this echo command, but instead of printing out who am I, it's going to print out JDO, and then it executes echo. So it works backwards, executing commands. And so if you're familiar with bash scripting, this is pretty straightforward. You've probably used it a ton, and I'm still pretty sure it's called command substitution. There might be like some other official name. Oh, you know what? They're calling it inline commands. Maybe I'm wrong. I could have sworn another term for it is command substitution, but whatever. I could be wrong. But either way, the name doesn't matter as much as understanding how this works. So in bash scripting, if you ever do the $ parentheses and then you can put commands in there, those are going to execute. So we can do that exact same thing here. Because remember, this pass-through command, all this does is essentially paste that into the command line. So now we have this in the command line, but instead of us putting a normal thing here like 1, 2, 3, 4, 5, we can put inline command is what they call it, or I'm pretty sure it's called a command substitution, but whatever. So when we do that, we essentially now have a way to enter whatever command we want, right? So now we got to use that to answer these questions. So what strange text file is in the website's root directory? So $ parentheses ls. Okay, so we have this drpepper.txt. That seems pretty weird, so I'm sure that's the answer. Yep. Okay, now it's asking us how many non-root / non-service / non-daemon users are there? Okay, so this one is a little bit trickier. How do you do this? So the way that you would do this is the way that I like to do it is, again, same thing. We're going to use that command substitution, right? And I'm going to just do this. There's probably multiple ways you could answer this, but this is how I like to do it. So if you just cat this out, then you can look and you can kind of examine all the users on the machine. And if you pay close attention, there's a few different things you can look at. I'll just give you one. And one that you can look at is this end, no login, where it says no login. That means that it's most likely not a user. So if you go through, there's actually nobody that has that. So you can just put 0. So there's actually no non-root, non-service, non-daemon users on the machine because all of these just have no login. So then what is this app running as? For that, you can just do the simple who am I command. And so that is Apache. So that's who it's running as. And then what is the user's shell set as? So this is going to go back. We can actually, oh yeah, cheating. So if we go back to this, we got to find it. Okay, Apache right at the bottom. So it's sbin / no login. Again, that's kind of what we used before to determine that there are no normal users. So / sbin / no login. And then what version of Alpine Linux is running? So again, there's probably multiple ways to do this. If you can think of one, you should mention it in the chat because it's always fun to learn other ways to do things. Because sometimes you kind of just get set in your way and then, you know, you don't learn as much new stuff as you could. I think that's it. Yeah, so I just cat the OS release, and usually that's what I do. So 3.16. Ooh, wait a minute. Alpine Linux version 3.16. Oh, version ID 3.16.0. 3.16.0. That should be right. Again, there's probably multiple ways to do this, especially this last one. Someone should comment and tell me if there's an alternate way to do it, because sometimes I go through these and I'm like, I know how to do that and I do it my way, and there's probably lots of ways. So that'd be fun to know. But yeah, so again, if you've read through all this, answered all the questions, now you should have a pretty good understanding of how all this works and how you can do a command injection. So with that, you finished task 10. And now it's on to task 11, insecure design. So insecure design, basically what this is this is just any vulnerability that is because of the way the application is made. And when I say that doesn't sound great. And I could see how if you're just getting started, that's confusing. But like if there's a problem, a security problem, just because of the way an application is designed and its flow and not necessarily anything specific, then that's insecure design. And honestly, the best thing I can do for you is just give you an example, and hopefully that helps. You can read through their example. They have this insecure password reset example, which I'm pretty sure is what we're going to do. So that is on port 85. And so let's see. So Joseph has a password. We're going to try and reset it. and I'll just say I forgot my password. Joseph There we go. Okay. So we have security questions. What's your son's nephew's neighbor's friend's name? Wow. What's your first pet's current address? What is your favorite color? So again, if you read the example, you kind of know what they're going for here. Red. Nope, that didn't work. Orange. I hate that I have to change this every time. Green. Oh, man. So now we have the new password. So you can copy that password. Oh, I guess I need to log in as him. Huh. So I'm going to enter that password first. And then it's Joseph. Dude, this key is driving me nuts. I need to get a new keyboard. Okay, not now. Private. Ooh, yeah, flag.txt. You can copy that and paste it in there. Submit that, and that's the flag. You can mark complete on the first question. So that's a pretty easy one. And again, the problem here is the insecure design, right? And part of that is, number one, their security questions were way too easy, and you could ask them multiple times, and it didn't send you like an email link to Joseph's email to ask the questions. It just took you directly to the page where you can try and answer these questions to get a new password. So there's tons of insecure design flaws in there, and there's some other flaws as well. But the one that they're trying to emphasize here is this insecure design. So the flow of the actual application, it's all wrong. It doesn't make sense, and it makes it very easy for someone to steal someone's account. So make sure you've read through everything and understand it. And with that, you're done with task 11. Now it's on to task 12, security misconfigurations. Okay, so again, some of these categories, and I kind of get it more now, but I remember when I was first learning, I was super frustrated because I felt like they were really broad and seemed kind of generic. But I'm doing the best I can with these like category definitions here. So the way I view security misconfigurations is that they are when security could have been appropriately configured, but was not, right? So it's an actual configuration issue, and a simple configuration, had something been configured properly, you wouldn't have the problem, right? And so again, not a lot of these don't have the best definition, but you just kind of learn with experience and going through the examples. So I want you to read through all this, and then it's going to tell you about debugging interfaces, and how Patreon got hacked. So we're going to do essentially, I think it might be the exact same hack or one that's very similar. So the way that we can do that is we can navigate to here. So that's port 86 is what I'm going to do. Okay, so now we're at port 86. This gives me a to-do list, different stuff. I can update, delete things. So again, you should always check out the website, look around, see how it works, and try to do some fun stuff with it. But once you kind of get a feel for the website, you can go down to the questions and navigate to console. So let's do that. /console. I keep doing that. Okay, so now we have this interactive console. And if you read up here, it talks about how when there's this misconfiguration issue, someone can go into this debugger console and they can actually run code. And this would be super easy to find in real life, because in real life, if you're pen testing a web application or doing security on it, you're going to do directory enumeration, and you would probably find something like /console. And so then once you found it, you could just mess around and realize, oh my gosh, this will execute Python code, which is exactly what it does. So we can take that, we can copy that, and then it wants us to paste it in here. So paste that code, and then we have all of this, right? And here's the actual command right here, this ls-l. So what was the question? What is the database file name? Okay, so DB, it's Toto. Toto.db. Modify the code to read the contents of the app.py file, which contains the application's source code. Okay, so instead of ls, what we're going to want to do is paste that again, but we're going to change this to cat app.py. So if we do that, so this is the actual source code. And if you read through this, where is it? Here we go. Here's the secret flag value. So we can copy that and paste that in. So again, this is pretty much a real example. This happened to, did it say Patreon? Yeah, Patreon in 2015. So security misconfigurations, they happen more than they should. So read through all that, make sure you kind of understand it. And with that, you're done with task 12. Now it's on to task 13, vulnerable and outdated components. Yeah, so this is a huge thing, and it happens on all sorts of websites, like so many websites. And it's unfortunate because everybody knows about it. So it's like the hacker knows that if it's outdated, there's probably an exploit for it, and they can just search on exploit.db and find it, or sometimes you can just search Google. And then it's also sad because the people in charge of the website, they should know when their components are outdated, and it should be as simple as just updating it to the latest version, and a lot of websites would avoid a lot of problems. But this right here, this is very low-hanging fruit for hackers. So this is where they like to go because it's really easy. I can just take a look at a website, see, hey, you have outdated, whatever, Lodash, jQuery, Bootstrap, I don't know. And then I can take advantage of that, right? And I don't even have to be creative or come up with it. I can just Google the CVE or the vulnerability that already exists for your outdated component on your website. So this is something you got to watch out for. Very common. So read through that, mark complete, and then we get to actually take a look at a real example. So look through all this. I want you to read through this because if you read through this, then the lab will be a lot easier. I'm not going to go through this because it's literally almost the exact same thing that we're going to do in the lab. You just get to read an example first, which is really helpful. The more examples you have, the better you'll understand something. But essentially what's happening here, Nostromo 1.9.6, probably super outdated. Yes, it is right up here. If you go to exploit.db, you find the remote code execution, and then you can just run it. And then when you run it, you probably just get shell, and then that's that. So I said I wasn't going to explain it, and then I did anyways, but whatever. So mark complete, make sure you've read through it, and then we'll move on to task number 15, where we get to do the actual lab. So that's going to be on port 84, and this one is actually pretty fun. So welcome to Online CSE Bookstore. The site has been made using PHP, so they tell you a bunch of stuff about this site, and you could look more into it. We have this project worlds down in the bottom right. There's an admin login, cart, books, contact, all sorts of stuff. So, yeah, maybe we'll look around for a sec, actually. Admin login, contact. What does contact look like? Books. This is our full catalog of books. And then publishers. Okay. So CSE Bookstore, online, latest books. Maybe we will view page source. See if we can find anything. Again, this is the kind of stuff that you should be doing anytime you're doing a CTF or in real life. And if you look through it, now if some of you are really savvy, you'll look through this and you'll see that they have outdated jQuery. And there's things you can do with that too, but that's not what they want us to do here. They want us to do some research, and as we go through, we'll not just do research here, but the other thing that they want us to do is they want us to take a look online, right? Go into like ExploitDB or something. So I'm going to do CSE bookstore exploit, right? And one of the things that helps me know that that is kind of what I'm doing is I can check out this project worlds.in, and this is free projects, free learning videos and free projects to learn programming, all sorts of stuff. And then I could literally go find, I'm not going to spend the time to look for it. Was it in PHP? Online food stuff, online bookstore project, PHP project. I could go in here. I could learn more about it. So again, examining the website will help you understand this, but then it's always super helpful just to Google stuff. And if you do Google it, you'll find this exploit. So you could Google it or you could search it directly on exploit database and you can read through it. And we know that this is the right exploit because it gives us this vendor homepage, that project worlds .in website that we just looked at, right? So we can take a look at all that. And then again, like I said before, anytime you use, especially if you're using an exploit, even if maybe you're not studying Python, maybe you're in school doing Java or something, I don't know. Anytime you use an exploit or you see some sort of script or whatever, you should read through it. Just give it to ChatGPT. It'll literally give you line by line and it'll help you understand it. And if you do that every time, you'll get really good at coding. So if we read through all this, basically, this is a script that's going to exploit the vulnerability for us. It's going to upload a web shell to this bootstrap/image, and it's going to give it a random file name and this URL. And we actually put in the URL. We know that because it's going to take the argument URL, right? So we're going to take that argument and yeah, so you can read through this. It's pretty straightforward. And then what I want you to do is once you've read all that, we are just going to copy the whole thing. So if I copy that whole thing, come over to TryHackMe, I now need to open up, did my terminal go somewhere? Where is it? There we go. Yeah, I'm going to open up a new tab. Oh, wait a minute. Yeah, close that old tab. I don't need that. And then we're going to nano exploit.py because I know that this is in Python. So that's why I'm ending it with that. And you can name it whatever you want. I'm just naming it exploit. And then we'll come in here. I'm going to paste the whole thing. And then I'm going to exit, which I did with Control X. And then I just answer yes. I choose the name. Now what I have to do is I have to add permissions. So I'm going to add my permission, and this is executable permission. So if you don't know what chmod is, it allows you to add or take away permissions to files. So what I'm doing here is I am adding plus X, so adding the execute permission to exploit.py. So now what I can do is I can do Python 3 exploit.py, and then again, if we go back to the source code here, we can see it takes the URL. So I'm just going to go back here. I don't think I need that index. I'm just going to take that. I'm going to copy, then give me back my terminal. And then I'm going to paste it in there. Okay? So if we run this, do you wish to launch a shell here? Yes. There we go. So it looks like it's working. Pretty straightforward. So now I can ls. Okay, so we can see we're actually there. What if I print working directory? We're in htdocs/bootstrap/image. Again, that's because that's probably where our shell was uploaded. So now let's see, what questions does it want us to ask? What is the content of the /opt/flag.txt file? So we can do that just by doing cat /opt/flag.txt. And if we cat that, here is our flag. Okay. So I just hope you realize how easy that was because they had an outdated component. Now, usually if something is so outdated that there's a remote code execution, somebody at the company will do something about it and it gets fixed. But there's other exploits that can very easily lead to remote code execution, and companies will sometimes just not update their components. So very realistic. This is probably my favorite lab on here just because of the concept that it teaches. So now we're done with task 15. You can mark complete and move on to task 16, identification and authentication failures. Okay, so what are these? Basically, these failures or these vulnerabilities come up when a system fails to verify and validate a user's identity in such a way that they're then allowed to access sensitive resources or action or do things that they're not supposed to, that kind of stuff. So if I can go to a website and if I'm not the admin user, but I can easily pretend to be the admin user and they don't properly vet me, that would be an authentication failure. Or identification and authentication failure. So read through all that. Here's some common examples. And once you've done that, you can mark complete. And with that, you are done with task number 16. Now it's on to task number 17, where we're going to do the actual practical part for this. So this is at port 8088. Okay, so we got this username, password, sign in, register. So this room kind of walks you through it in a pretty easy way. So if you read through all this, it'll literally tell you exactly what to do. So yeah, say there is an existing user with the name admin and we want to access their account. So you can re-register that, the admin user, but with a slight variation. So that's what we're going to do, but we're going to do it with Darren. So try to register with Darren as your username. So let's try that. Darren, password, just put whatever you want. And then invalid username or password. Did I put in Darren wrong? Oh no, it wants me to register as Darren. My bad. So Darren, we're going to do the email, password. And then if we register, error, this user is already registered. Okay, so then it asks us to try to register Darren with a space and see what happens. So now I'm going to do the exact same thing, but I'm going to put a space there. So space Darren, email, and then the password, I'm just going to do ASDF, register, not now. Okay, so it says I was registered successfully. So if I do space Darren and then ASDF, that allows me to sign in, and I assume this must be the flag, right? That's not a flag looking format, but I think that's it because it matched. Yeah. Okay. So now it wants us to do the exact same trick, but with Arthur. So I'm just going to log out, re-register Arthur. Exact same email, exact same credentials. And it says I registered. So now space, Arthur. And I get the second flag. Okay. So you're probably wondering, why does this work? Why doesn't everybody do this to every website? Well, this website, like most things in TryHackMe and in CTFs, is very poorly implemented, because essentially what's happening here is, in some way, and I can't explain how, because I don't have access to the back end of this website, so I don't know exactly how it works. But in principle, or in theory, what's happening is the front end of this website is accepting it recognizes the difference between Darren with no space in the front and Darren with a space in the front. So the front end is basically saying, hey, this is a brand new user. We need to register them, and then it creates that account. Now the problem is when we actually, either when we log in or something else on the back end, but something later is registering this instead of as a new account on the back end, they're registering this as the same Darren account that doesn't have any spaces. So then when the server is actually working and creates us this new Darren account, it doesn't create a new account. It recognizes this as just the old Darren's account and updates the information, right? So the exacts of how that are happening aren't really known, because we would need access to the back end of this server to see how it's implemented. It's obviously implemented very poorly, because your front end is viewing this as like different users, and then when you try to actually process it to register the user, the back end is just treating it like the same old user but updating information. So that's super bad. But that is an identification and authentication failure, right? Because we are very easily able to become the admin user or Darren or Arthur, even though in actuality we are not any of them, right? So make sure you read through all that, and once you've done that, you can mark complete, and you're done with task 17. Now it's on to task number 18, software and data integrity failures. So this is going to talk a little bit about integrity, and basically what that means is that you can trust. If something has integrity, you can trust it. So that means if a piece of data or a software has integrity, that means you know that it is unmodified and it's not bad, it's good, and that it's only been modified by the appropriate people, right? So a quick definition that I use, it's how reliable it is, right? So it needs to remain trustworthy unless changed by an authorized person. So an example here is this WinSCP, this is the example they use, and they talk about hashing and how hashing can allow us to confirm whether or not it has integrity, right? So if I send an email to a friend and I hash that email before I send it, and then he gets it, and then he hashes the email, he can compare our hashes. And if they're the same, that means the email is the exact same. Now, if somebody in between us were to change my email, let's say a bad guy intercepts it, they change it, and then they give it to my friend. Now when he checks the hashes will be different. So this kind of idea is in everything. I mean, we use it all the time. This is a big part of the reason why hashing is so important. And yeah, it's because it can provide us with this integrity, right? It's a way to actually visually see and calculate and measure whether or not a file has been changed. So make sure you read through all this and kind of understand how it works, because we're going to be using it in the software and data integrity failure. So mark complete once you've read through this and you're done with task 18. Now it's on to task 19. So what task 19 is talking about is again the same thing. So let's say you have a website, right? So yeah, this is your website. Somebody says, hey, I want to go to your website. So they send a request to you. You send them back a request with all of the HTML and all of the information that they need so their browser can display that website. Now, one of the things that you send them is this script that has the source for jQuery.com, jQuery.js. So this is an example up here. So essentially what you're saying is, I don't have this jQuery code all the code that's right here for this 3.6.1 version of jQuery, I don't have that just sitting on my website, right? I don't store that in my site because I don't want to pay to store it or whatever. I don't know. So instead, what you do is when you send them over the HTML, you give them this script with this source and you say, you reach out. So essentially the web server, instead of doing the work, they're going to make you do the work. So then they're telling you, hey, you reach out to this URL and you get the source code for this jQuery.js. And then once you get that, then you'll be able to view my website and use it. So that's kind of the process right here. So you can look at that and walk through it. But that's how it works. Okay. And that's called, so you have this script and it's third-party sourced, basically. So make sure you read through everything. And then what we're going to do is you also need to know about this, which is this website that'll help you produce one of these. And what this is you get this integrity hash. Because here's what can happen, okay? Let's say I go to a website. Now this website, they're totally fine. They're 100% secure. They are very careful about what they do. But like I said, they don't keep this jQuery code on their website. That jQuery code is over here at code.jquery.com. So they just tell us in the middle here, they say, I don't have that because it's on code.jquery.com. You go get it. So then I go get it and then I bring it back and I display it in my browser. But what happens if a hacker doesn't break into the website, but they hack into code.jquery.com? And then what if they go in and if they change this jQuery.js from normal jQuery.js that we need to something malicious that's going to do something bad to our computer, right? Well, this website just told us to go get it. We're going to go get it, and then we're going to have malware on our computer, right? Because someone hacked into code.jquery.com. So the way that the website helps prevent this is they can use an integrity check. And they do that by just using a hash. So what they do is when they build their website, they go to code.jquery.com and they check out this code and they review it. And then they say, okay, we know that this code in its current version is good, right? The way that it's good as is. So what they're going to do when they know that this code is good is they create a hash. They then put that hash in their HTML in this integrity section right here. You can see if you look at this whole thing and you know a little bit about HTML. So now we have this hash. So now instead of our website just listening and going and getting this directly from code.jquery.com, now what it'll do is before it uses it, it'll check the hash. So it's going to look at the hash in the HTML, but then when it gets this code from jQuery.com, it's going to hash the code itself, our computer is. And it's going to say, hey, does this hash match this hash that I got from mywebsite.com? And if they match, great, it's going to use it. If it doesn't match, then that means that this code over here has been changed. And so because of that, it won't run it. So this is a way that we can prevent my previous example of someone hacking into code.jquery.com from affecting people. Because in case you don't know, jQuery is used by millions, maybe even billions of websites. So if code.jquery.com got hacked and people aren't using this integrity check here in their HTML, then all of a sudden you're talking billions of people would have malware on their computer because jQuery is used by almost everybody, right? So again, to prevent that, a good website can use this integrity check here. Now, this is a pretty simplified example, and websites have kind of other methods of doing this. If you look at the source code of a website, you may not always see this, and this poses other issues because, if jQuery is updating constantly, then you might run into some functionality issues with your website and yada, yada, yada. There's a lot of caveats to this, but the main concept is what I want you to take away from this, right? Which is you can integrity check third-party scripts that you download onto your website. And that's pretty cool. So what we're going to do is we got to go to this site here, and it's just going to have us copy and paste this into the site. So what this does is we tell it what third-party script or source that we're using. And I'm pretty sure the question said 256, right? Yeah, a 256 hash. So what we can do is we can just put the URL, and then this SRI hash generator will automatically hash it, and it gives us the HTML for the integrity check. So now we can just copy that HTML, and in real life, we could just paste that directly into our website, right? Oops, that must have not copied, and I'm not sure why. How about that? Does that work? Oh my gosh, I'm so stupid. This is limited. They just want the hash. Okay. So all they want is this. And that, ladies and gents, is why it's important you read more carefully than I do sometimes. Because I was getting excited, because the whole point of this website is you can copy and paste this straight into your HTML and it'll do the integrity check, but they don't want that in the question. They just want the actual hash. So fill that out, mark complete. Once you've read through everything and understand this, you have finished task number 19. Now it's on to task number 20, data integrity failures. Okay, so data integrity failures. Same idea as software integrity failures, right? Except for instead of entire software and entire code bases or code libraries, we're just talking about, a little piece of data, which may not seem as important, but trust me, it can be. So I want you to read through all of this, and it's going to explain a handful of things. It's going to explain a little bit about cookies. Hopefully you know a bit about cookies at this point, but they help store data for us. So an example, when you log into TryHackMe.com, you log in the first time and the website says, hey, I know that this is you, right? So when I log in, it's like, I know this is the helpful hacker because they gave me their password and their username, right? So it does all the checks. But then let's say I click to a new page. How does it still know that it's me, right? Like, because it wants to be able to regularly check, hey, are you who you say you are? So a big part of cookies is what TryHackMe can do is when I log in, it will send me a cookie that is unique to me. And it says, here's your cookie. Now, anytime you ask us for anything, we know it's you. So if you ask us for sensitive data for your own account, we'll give it to you. If you ask for sensitive data from someone else's account, right? Maybe because of an insecure direct object reference, tying it all in together, we're not going to give it to you because you don't have their cookie. You have your cookie, and your cookie is just for you, right? So that's just one example. You can use cookies. They got a ton of functionality. They're super cool. But yeah, you should read through all this. And then another important thing that you got to learn about here is a JSON web token. So what those are, they're tokens that let you store key value pairs, and they provide integrity as part of the token. So integrity, we talked about that before. What that means is we know that nothing's changed, right? So in this example, again, like with my cookie example from TryHackMe, now we're just going to talk specifically about JSON web tokens. So read through that, but here we have, this is the format of a JSON web token. So here it says the type, it's the JSON web token, JWT, the algorithm, and this algorithm, this has to do with the signature, okay? And the signature is important. And then we have the payload. So this is the information. So username, guest, expiration date, like this is when this JSON web token expires. So let's say I logged in, right? The header is going to be the same. The algorithm is going to be the same. But instead of username guest, it's going to say helpful hacker. And then it's going to have my expiration because it only should last for a while. It shouldn't last forever. That would be dangerous. And then there's the signature. So the signature is unique. And if somebody were to change the username, let's say somebody stole my web token, and let's say they changed the username to, I don't know, let's say we're trying to be the admin. So we change it to admin, and then we send the web token. Unfortunately, it won't work. Well, not unfortunately, it's a good thing for internet security, but that won't actually work because this signature won't be correct. So this signature makes it so that if you change anything else, the signature will change, and then it just won't work, right? So the signature is this very important part of the JSON web token. So again, you have the header, dot, then the payload, dot, and then the signature. So that's the three parts that make up a JSON web token. Now, JSON web tokens, they're generally just base64 encoded. That's important to know. So read through that, and then you can use an online tool to encode or decode base64, blah, blah, blah. Make sure you read through all that. And then, so this algorithm, sometimes, and this is mostly avoided today because people are more careful, and if you try to put algorithm none, then the web token is automatically like not accepted today. But when web tokens were like first out and about, and I'm sure there's still websites that don't do that, you can put algorithm none, and then you can change the payload, and there is no signature, right? Because there is no algorithm. So if you put none for the algorithm value, then no signature is required. You can just send a non-signed web token, which is dangerous. But sometimes that actually works if a website is not well built. So that's what we're going to do today. So I'm just going to walk you through it. That's on port 8089. So it asked us, I didn't read it, but I saw it. So it wants us to sign in as guest, and we'll just guess a password. Invalid credentials, you can also log in as guest with password guest. Okay, so we'll do guest, and then guest, and then we'll log into this website. So now what it wants us to do is we have to go to the inspect. So inspect queue. So you might be doing this in Chrome. That would be like dev tools and stuff. Here I am in Firefox because that's what's on the TryHackMe box. So here we can go to storage, and this is where all of our cookies are stored here. So this is the website we're at, and if we look, we have two cookies. We have this PHP session ID, which we're not going to mess with, and we have this JWT session, which stands for JSON Web Token, which, oh my goodness, that's what we've been learning about. So that's probably where we need to focus our efforts. So we'll answer this first question because we figured that out, which is guest. And then it shows you right here where to find those cookies. So we found all these cookies. Now what we need to do is figure out the name of the website cookie containing, what is the name of the website's cookie containing the JWT token? That's the JWT/session or dash. So dash session. There we go. Then use the knowledge gained in this task to modify the JWT token so that the application thinks you are the user admin. Okay, so very similar to this right over here, right? So I'm going to show you something. Okay, so this is a JSON web token decoder or coder. I really like it. So what I'm going to do is I'm going to take that, copy that value, and then I'm just going to paste the token in there. Oops, that did not work. I want to copy that whole thing. The JSON web token should be longer than that. And then we'll paste it. There we go. Okay, so now if I enter that, it automatically breaks this down for me. Now, if you notice, there's the header and the payload. it totally ignores the signature which is this last part. Because if you try to mess with the signature, it's just not going to work. Because yeah, it's a signature. The whole idea is if you mess with it, it doesn't work. And if you base 64 decode it, it still won't really work. Now, I explained more about signatures in the hashing basics, I think, or maybe it's in the cryptography basics room. Yeah, I think it's in the cryptography basics room. So if you want to learn more about signatures and how they work, you can check that out. But for this example, all we really need to know is that if we change anything else, the signature will let someone know that we changed it, which is no good. But as we learned when we read, and from what I told you, if we put none here, then we actually don't even need this signature. So I'm going to put none, and then I'm just going to erase the signature. And instead of guest, I'm going to put admin, right? And this website's really cool. It gives us, this is the actual token. So I'm going to try and copy that. And now what we can do is we can take that token value and we can paste it in there. And then if I hit enter, and then if I try to get the flag again, it'll say THM, don't take cookies from strangers. Okay. So yeah, this is a very easy way to do that. You could do this manually using base 64 encoding and decoding. I'm not going to get into the, I always say I'm not going to get into the nitty gritty. And then I just end up going there anyways, man, because why not? But if you do this manually, so if you didn't use this website, let's say you just decoded it, and then you took this and then you encoded it again. There's a couple of things that you should remember so that you get the question right and so that it doesn't yell at you. One of them is make sure you have a dot here and make sure you include that dot at the end. And then also, I don't know for sure, but I think that if you do it yourself, there's this thing when you base 64 encode called padding, and it looks like this. So I'm actually going to test this out and see if it still works. So this is what it would look like if I did this by myself and added the dots. So if I base 64 encoded this, put a dot at the end, and then I base 64 encoded this, put a dot at the end of that, and then if I combine them together, I think this is what I would get. And if you can tell the difference, I mean, I just added those equal signs at the end. So I'm actually going to try and see if this works. Because what those equal signs are is they're called padding. And so I want to know if you can still get the flag. Okay, great. I was wrong. For some reason, I was under the impression that it wouldn't accept padding if you did this manually, but I guess it totally does accept padding. Now, in real life, I'm pretty sure JSON tokens, for the most part, they don't have this padding. So they usually don't have any of these equal signs. Those are just removed. And I'm not going to get into the details of how padding works with base 64 encoding and decoding. If you want to learn about that, you can Google it. It's actually pretty interesting. But yeah, so hopefully you understand a little bit more about JSON Web Tokens, about cookies, and how, if implemented improperly, you can alter them to make a token or a cookie say whatever you want. And if you can do that, that's really dangerous, because then the website might think you are someone you're not, and that is a data integrity failure. So once you're done with that, mark complete. Now it's on to task 21. This one is really easy, but it's important. So security logging and monitoring failures. Basically, all this is when an issue arises because an application or something is not properly logging everything. So, maybe your application isn't logging what it's supposed to, and then something happens and you go back, you look at the log to try to detect what's going on or to respond to an issue, and all the relevant security events are not kept, right? That would be logging and monitoring failure. Or maybe you are keeping track of logs, and they're pretty good, but you're not monitoring them properly. So even though you are capturing like what's going on and you see it in the log, if nobody's monitoring the logs regularly, if you don't have a SIEM or something, that's also a monitoring failure, right? So read through all this. You can learn a little bit more about logs, what's in them usually, what's not. It varies quite a bit based on what you're doing, whether you're using a web application or something else. In this example, we're talking OWASP, so very web application specific. But yeah, read through all this, and then we are going to download the task files. Okay, so I downloaded those, and they look like this. Okay, so this is what we got here. We got a bunch of these unauthorized, and they all look like they're coming from the same IP address, which is bad news. So with that, we can answer this first question. That's the IP address of all the unauthorized submissions. And then it asks us what kind of attack is being carried out. So this is a brute force attack. And you know that just by reading all of this, and it's like one of the only things that fits in there. Plus, if you look at this, you can see they're trying admin, administrator, anonymous, root. They're just trying to brute force and guess the correct username to log in to this, right? Maybe it's an application where you only have to put in your username, or I don't know. Could be lots of different things. But yeah, so we can tell just based on their guesses and all these unauthorized, and that they're all from the same IP address. This guy with this IP address is trying to get in as an administrator of some kind, and he's just guessing. So that qualifies, I guess, as a brute force attack. So mark that, and once you've read through everything, you can mark that complete. Now it's on to task number 22. Server-side request forgery. Okay, so this one, I like this one. Server-side request forgery can get pretty complex. They give us a really good example that makes it pretty simple. So if I have a website and it's mysite.com, and let's say it has this, so this question mark, what the question mark means is that just means that, what's it called? It's a parameter. I don't know why I had a brain fart. Couldn't remember the name. But yeah, so that's just, it separates the normal URL from the parameters, right? So the parameter here, because of that question mark, is the server. And what is the parameter for the value server? And it's srv.3.sms.thm. And then you also have the parameter message equals hello. So we have these two different parameters here, and one of them is server. So what we can do is it kind of walks us through this. So we send this request to mywebsite.com, but then my website reads this and sees that what we actually want is located at server srv3.sms.thm. So now my website is going to reach out to them, and it's going to get what we're asking for. And then it is going to send it back to, all the way back, and we'll get whatever it is that we're asking for. But essentially what's happening here is we are telling the website a server to go to. Now what we can do is, if we're hackers, we can change this value and tell the website to point to a different web server. And that can get really dangerous really quick, because we could start telling it to point to all sorts of things that it maybe shouldn't be pointing to, and trying to get things from it. And we might even be able to get an API key, right? And it explains that if you read through all this. So make sure you read through that and understand kind of the concept of what's going on. And then here they give you they get more specific, and they can say, instead of just sending my website to any server, we could actually send my website back to us to steal that API key, right? So if I set up my own web server that's bad and tell my website, hey, I want you to go to my server instead of this SRv3, it'll send it straight to my server and it might expose something that it shouldn't. So that's the example that we're actually going to run through. Again, explaining it's nice. The examples are always way better. So this is on port 87. 87. And you can get out of dev tools. I don't know what it's actually called on Firefox. I know it's Chrome Dev Tools. I don't know what it is. If you know that, you should let me know. Okay, so down to the questions. What is the only host allowed to access the admin area? Okay, well, home portfolio about, admin area. Okay, so admin interface is only available from localhost. And if we look at the URL, it's /admin. So the local host is the only one who's allowed. Check the download resume button. Where does the server parameters point to? So if I go to, where's download resume? Oh, here we go. Download resume. So I'm going to actually copy the link because if you click on it, it's just going to take you straight there and download this dude's resume. But I don't want to do that. So I copied this link. So now if I come over here and paste it, oh, come on. I could have sworn I copied that link. Copy link. Why does that not want to work? You know what? I'm going to open up another tab. Oh, that's why it doesn't want to work. Again, this is, so it just wants to know where it points to. Okay, it doesn't want the entire link. So it points to this secure filestorage.com. So let's paste that in, hit submit. Okay, now it says using server-side request forgery, make the application send a request to your attack box. Okay. So if we're going to send it back to our attack box, hopefully you read through this material right here, because what we're going to do is before we actually do that on this guy, we need to start a listener because we need something for it to connect to, right? So I'm just going to open a new terminal and so what we're going to do is we're going to do netcat-lvp and we'll do port 4444. Okay. Oh, wait, did I actually? No, I got to execute that. Okay, so now we're listening on our IP address port 4444. Now, another thing I need to do is I need to get my IP address. So if I go to IPA, I can look through here. And I don't really love the way this looks, but, oh, here we go. Number 2. Okay, I'm pretty sure this is our IP address. Yeah, that's link loopback. This is Ethernet. This is another Ethernet, but that looks like a Docker thing. Yeah, okay. So copy that. I'm going to need that. And then we're still listening here. So now what I'm going to do is instead of server equaling this secure filestorage.com, I'm going to backspace and then I'm going to paste. And now this is going to port 8087. I don't want that. I want 4444. Now, let's see if this works. So all I did was I started the listener and then I'm pointing the server to my listener. Okay, so I entered it and nothing's happening, which is actually a pretty good sign. because now if I open my terminal, okay, see, we can see it connected. So it connected and it gives us the flag. So let's copy that. Oops, I just canceled my listener on accident. So let's paste that and hit submit. Awesome. Okay, now we can go the extra mile here. There's a second server-side request forgery, and we're going to figure out how to do it. So the way that we do this is pretty simple. I'm going to start my listener again because I'm going to need that. And what I'm going to do is, if you look at the question, we want to gain access to the admin area. Okay. So if we remember this, the admin area is / whatever it was. I can't remember. So yeah, I think it was just / admin. Yeah. So I'm going to copy that link. I'm going to come over here. I'm going to paste it. So this is the original link. But now what I want to do is I actually want to send it to, or I guess I wouldn't want to send it to that. I want to send it to because remember, there's only one person's allowed there, and that is localhost. So I think if I send it to localhost at 8087 and ID equals 75482342, we can try that and see what happens. But before we try it, I'm going to copy this. So let's enter that. Okay, and it still gives us the regular download, right? So I know this because I've done this before, but if you put %23 in front of this, oh, wait a minute. I didn't actually do it right. I got to do / admin and see if that works. Now, if I go back to my terminal, why is this not downloading? It didn't get anything. Okay. So I only know this because I, researched it and spent a lot of time to figure it out. But here you actually have to put %23. And what %23 is, and then if I run that, here we go. Okay, we get that flag when I run that. So that's the flag. Now, the reason why we have to put %23 is because %23 is the URL encoding for the hash symbol. Now, I don't want to get too deep into it because this video is already way too long, but the hash symbol basically, it normally directs you to a specific portion of the page, and oftentimes it's ignored by the back end. Not always. Anyways, it's basically hash, the question mark. There's specific symbols in a URL that can be interpreted differently and kind of have different purposes, and they're kind of special. Okay. And so in real life, the way that you would find a server-side request forgery like that is you would have built the initial part without the hashtag 23. And then you probably would have placed something here and fuzzed it. And you would have inserted multiple special values to see if any of them would counteract this whole ID 75482342 thing, because you don't exactly know. I mean, it's an ID number, but you don't exactly know how it's all being processed on the back end because you don't have access to that. So in real life, that's how that would be found. And that's not unusual because people know, if you do a lot of web app pen testing, you'll know what the special URL characters are. And so you can URL encode them and start messing with them to see if any of them have an effect. And that's really the only realistic way that anyone would see this. Now, I found it because if you go on the internet and look and Google it a bunch, there's people that explain how the hashtag actually works in this specific instance. But we won't get too deep into it. You can just Google it yourself to understand how that works. But again, it's URL encoding the hashtag value, which on the back end is making the server-side request forgery work because the hashtag is a special URL value. So yeah, read through all this. Again, make sure you have a good idea of server-side request forgery, how we're pointing to a third server and we can manipulate that. And with that, you are done with task 22. Now you can just see what's next. There's other rooms. You can keep going on this pathway. Mark complete. And with that, you have finished the OWASP Top 10 2021 room from TryHackMe.